So let's see, for question number 4, we're picking up part number 2 on Algebra 2, Lesson 57. On question number 4, if you want to see an example of this in your book, it's example number 2. We got a massive iodine 131 atoms decay in such a way that half decay every 8 days. What portion of the original remains after 24 days? Now there's a formula to this, but I'm going to give you kind of a common sense way of thinking about this. If half of it is gone every 8 days, and we're looking at how much remains after 24 days, we want to see how many half-lives it's actually going to go through. So you're going to take 24 divided by 8, and you're going to see it's going to go through 3 half-lives. So imagine this, if we're looking at what fraction remains after 8 days. So at 8 days, you're going to divide that in half. So I got half here and half here, okay, half of a whole. On day 16, okay, you're going to, obviously do away with that after 8 days. On the 16th day, you're going to take what you have remaining and you're going to cut it in half, which by all rights is a fourth of the original, and you're going to get rid of that fourth. Okay, and then on the 24th day, you're going to take what's remaining and divide that in half, leaving you with 1/8 and 1/8. So what you have remaining after 24 days is 1/8 of the original. Now, the way that they kind of show this as a function is going to look like this, is that f of 8 equals 1/2, let's see, where we'd get f to the 0. All right, so b actually equals the 8th root of 1/2, which equals 0.917 to the 24th. Okay, you could also get that, which equals 0.125. And 0.125, if you hit math fraction, is 1/8. But you can see where, in this question, it's easy enough just to kind of common sense it out to get the 1/8 rather than going through the rest of it. Okay, in either case, you should know what work you need to do. If you have questions about number 4, please ask me in class. If you see a question like this, you need help with it. Okay, question number 5. Question number 5 is different than question number 3 because it's a compounding continuously question. So this comes from example 1b. We looked at example 1a earlier. You can go down and look at their solution for 1b. Again, it's a good idea to look at your examples in your book, change the numbers, okay? Make sure that you understand the example. Okay. Let's see, there you go. All right. So in this question, we're going to start off with our principal. Our principal is $2,500. Okay, and when it's compounding continuously, we're going to use our E. Hey. I'm trying to do something here, so if I can keep you guys quiet, it'd help me out. I'm going to be done here pretty quick. All right, so then we're going to take that with our rate times our time. So if, a better formula for this, just so you're seeing, whenever we're compounding continuously, it is principal times E to the rate times time. So our principal is $100 to the E times our rate, which is 0.035, and our time is 3 years. Okay, the rest of this is just plugged into the calculator. So all I really need to do, let's clear that out. We got 2,500. We're going to hit second natural log so that we're getting 0.035 times 3 when it's compounded continuously. At the end of those 3 years, I have $2,776.78 because we want to round it to the nearest cent. Okay. So I don't know if it'll let me. That's what you want right there. All right, last question, and then we'll be all done. Okay, Cheryl invests 387% compounded continuously. So we're going to go back to that formula that we used in number 5. We want an exponential function to model the situation. So we're going to go back to that. So our principal is $380 to the E. Okay, 7% is 0.07 times time, because they don't tell us our time. So this is our A. It's all we need for part A. Part B, at what time will the total reach $800? So we're going to start off with 800 is going to equal 380e to the 0.07 times t. Okay, so this is where we end up solving this the same way that we solved number 2, where we had the bacteria. It's the same formula that we used there. We start off by dividing by 380 because we're trying to isolate t. 800 divided by 380 is 2.105, and you can get your calculator and check that for me. Okay, and that's going to be e to the 0.07 t. Now, if you remember, we take the natural log of 2.105, and that's going to equal the exponential, what we're taking e to the power of. So that's going to, that number will equal 0.07 times t. So the natural log of 2.105 is 0.744. So 0.744 equals 0.07 times t. The last thing we need to do is divide by 0.07 to find t. T equals 10.63486 years. So if we've got $380 to put into a savings account, in 10 years we'll have $800, or closer to 10.5. So that should be the rest of what you needed for lesson 57. Hopefully some of that makes sense. If it doesn't, then by all means stop the video, raise your hand, ask a question, email me, write in the comments section.